The other day we discovered a relationship between the ratio of the side lengths, which is the scale factor, and the ratio of the area. It is scale factor squared equals ratio of areas. We can also say ratio of the side lengths equals ratio of areas. Very important. That's what we're working on right now. Now, if we want to find the scale factor and we're given the ratio of areas, we take the square root of the ratio of areas. Works both ways. Scale factor squared gives us ratio of areas. If we're given ratio of areas, we take the square root, we can find the scale factor. So when you're reading through these problems, you have to determine what's given to you, either scale factor or area, to determine what you need to find. So you're either going to take the square root of something or you're going to square something. A figure is enlarged until its area is 144 times the area of the original figure. By what number was each length in the original figure multiplied? So we have to look at what we are being asked to find. We're looking for the length. We are given 144 times the area. So we are given the ratio of the areas. So we need to take the area and change it to the scale factor. Area to scale factor. So we're given an area, we need to find the scale factor. So that means we need to take the square root. So the scale factor would be equal to the square root of 144, which equals 12. The circle with a radius of 4 centimeters is enlarged by a scale factor of 12. How many times the area of the original is the area of the larger circle? So we're looking for area. We are given a scale factor of 12. So we're given scale factor, we need to go to area. Scale factor to area. Scale factor to area. Scale factor squared gives us the ratio of areas. So the area will be equal to 12 squared, which is 144. Example 3. A rectangle with an area of 60 square meters is enlarged by a scale factor of 5. Find the area of the larger rectangle. So we're asked to find the area. We are given scale factor. So we are going from scale factor to area. Scale factor is 5. So the area is going to be the scale factor squared. So it's 25 times larger. And this one, we are asked to find the area of the larger rectangle. The original is 60, so the new rectangle is going to be 60 times 25. The area of the new rectangle will be 60 because that's what we started off with, and this new one's 25 times larger. 60 times 25 gives us 1,500 meters squared. Carlos Pizza Shack charges $12.50 for a pizza with a diameter of 25 centimeters and $22 for a pizza with a diameter of 40 centimeters. The two pizzas are similar. Determine the scale factor when comparing the larger pizza to the smaller one. So we're asked to find scale factor. We need to compare larger to smaller. Scale factor equals large pizza has a diameter of 40. Small pizza has a diameter of 25. So 40 over 25. It's okay to leave it like that, but we like working with smaller numbers. Reduce, we can divide both of them by 5. So we have 8 over 5. Find the ratio of their areas. So we have ratio of areas is the scale factor squared. 8 over 5 squared. Eight squared, 64. 5 squared, 25. That's all you need to do. Use the ratio of the areas and the price of the smaller pizza to determine a corresponding price for the larger. So we are trying to find a corresponding price for the larger pizza. That's our unknown. And we're asked to use ratio of the areas. So you're told to use ratio of the areas, that's 64 over 25. And the price of the smaller pizza. So you're setting up a proportion to find the corresponding price for the larger pizza. So 64 corresponds with the larger pizza. So that's where your X goes. The price of the smaller pizza corresponds with a 25. Small pizza is $12.50. Let's do our cross multiplication. 25x equals 64 times 12.50 divide both sides by 25. So the cost of the larger pizza is 64 times 12.50 divided by 25. So the cost of the larger pizza should be $32. We're actually charging $22 for the larger pizza. So if we go based on the price of the smaller pizza, we should be charging $32, but we're only charging $22. So D asks us to decide what pizza is the better buy. And the larger pizza should be $32. We only charge $22. So proportionally, we should be charging this much. We don't really charge that much. So the larger pizza is the better buy. Because it's cheaper proportionally. A professional basketball player, 227 centimeters tall, has a footprint with an area of 441 centimeters squared. This basketball player and Nelson have similar bodies. If the area of Nelson's footprint is 324 centimeters squared, how tall is Nelson? So we're looking for the height of Nelson. We know the height of the other basketball player. We know areas of their footprints. Now, we need to set up a proportion, but this is one-dimensional, these are two-dimensional. So what we need to do is we need to take this, find the scale factor, because then we will have a one-dimensional scale factor that we can set up. So we need to take our area and change it to scale factor. So we have 441 over 324. Doesn't matter who you put on first, that's numbers or that the numbers were in, so that's why I took them. So square root gives us 21 over 18. Now I have a scale factor. I'm going to use the height of this basketball player to find the height of Nelson. So 21 over 18. The 21 corresponds with this basketball player, which is 227, and Nelson corresponds with 18. So that's where we'll put the x. Now we can cross multiply. 21x equals 18 times 227. Divide both sides by 21. So Nelson is 18 times 227 divided by 21, so his height is 194 centimeters. The size of a television screen is typically reported in terms of the length of its diagonal. So the diagonal for your television screen, diagonal from this corner up to this corner. For example, if the store advertises a 42 centimeter screen, this means that the length of the screen's diagonal is 42 centimeters. What is the ratio of the area of a 52 centimeter screen to the area of a 28 centimeter screen? So you're asked to find the ratio of the area. So we can take scale factor. So we're doing scale factor to area. We have 52 over 28. You could reduce it if you wanted to, but we don't have to. So if I wanted to reduce it, I could divide both of them by 4. That would give me 13 over 7. So then 13 over 7, square that. 13 squared, 169 over 7 squared, 49. What is the length of the diagonal for a screen with 3 times the area of a 23 centimeter screen? So you need the length of the diagonal. That's a one-dimensional measurement. The area is 3 times. So we need to take the area, change it to a scale factor. So area to scale factor. So 3 times the area, that means we're taking the square root of 3. So we have a scale factor of 1.7. Now, we're comparing it to this 23 centimeter screen, so we have to take this scale factor and multiply it by 23. That will give us the length of the new diagonal. So 1.7 times 23, 39.1 centimeters. Example 7. Determine the area of a right triangle with the sides that measure 6, 8, and 10 centimeters. So we have right triangle, longest length, always on the hypotenuse, 6 and 8. Doesn't really matter where those go. So area of triangle, 1/2, base times the height. So we have 1/2 times 8 times 6 gives us half of 8 is 4 times 6, 24 centimeters squared. Use your answer to part A to predict the area of a right triangle with sides that measure 12 centimeters, 16 centimeters, and 20 centimeters. So we have 20 in the hypotenuse. The 16 correlates with the 8, so that needs to go in the same spot, and the 12 correlates with the 6, so it needs to go in the same spot. So we're asked to predict So that means we're going to use a scale factor to area ratio to predict our new area. So our scale factor, doesn't matter which sides we choose, we have a scale factor from the new one to the small one, so 12 to 6. Gives us a scale factor of 2. Once we square that, that's our ratio of areas, so it's 4 times larger. So 4 times 24 will give us a new area of 96 centimeters cubed. Verify using the formula for the area of a triangle. 1/2 16 times 12. 96 centimeters squared. You need your textbook to complete your assignment. If you need to leave, you go get it. You will have a tardy.